we're going to move to chapter 3. And chapter 3 is your determinant section. And so, we're not there yet, but here are the sections that will be on chapter 3. You don't have to worry about this until next week, but we had to keep going to stay ahead. So this test is going to cover 3.1, 3.2 through 3.4, and 7.1. And what 7.1 is the eigenvalue section. So that was on that worksheet number 2, where you had that last problem number 21 about the eigenvalues and eigenvectors. That is what that is. Usually, this test is pretty easy for you. You like determinants. Determinants are another one of those arithmetic operations, that you do pretty well on. All right, so here is, I'm actually going to skip over section 3.1 because we don't have a lot of time today, but we have a little bit of time that we can get some stuff going. So I'm going to skip over section 3.1 and go to section 3.2, and here are your notes for that. Because section 3.2 is quite, I guess it's theoretical. Okay, so while I am writing this up, I want you to take the determinant of these. You don't know why yet, but I want you to take the determinant of them. Right, so in this section, again, this is section 3.2 because we're skipping over 3.1 for now. We're going to get it. We're going to come back and get it. But what we skipped from section 3.1, there are certain things that you already know. And so I'm going to write that up anyway so that you'll have it. So the determinant okay, and first of all, that's the correct spelling of determinant. Sometimes you think I'm saying determinate, like we do in Cal 3 when we talk about indeterminate forms, but it's not determinate, it's determinant. And so that's how we spell determinant, just making sure we're on the right page. The determinant of the matrix is given by this formula. Okay, so there's two different ways to write the symbol for determinant. You can write it where it looks like absolute values, but remember that's not absolute values in this context. That's your symbol for determinant, or you can write it as DET. And the way that you find the determinant is you multiply down your main diagonal, which would be A11, A22, and you subtract your secondary diagonal product A12, A21. And that is how you find the determinant. And the determinant is a number. The determinant number is not a value other than being 0 or not 0. And so what I mean by that is I might have a determinant of 1,000 and I might have a determinant here of 4. and one's not bigger than the other or have more value than the other, the only thing that we're going to use for determinants in future studies is, does it equal 0 or does it not equal 0? And that's going to be huge for us the rest of the semester. Does it equal 0 or not? So that is your formula. Do you have any questions with that part? All right, so let's go through and find the determinants of all of these, and I broke them into little groups, of all these little groups. Okay, so the determinant of this one was 8 minus 3. So my determinant here was 11. And of course, you don't have to write all that out. You can do it in your head also. I'm going to go back to my sheet really fast. There we go. And the determinant of this one, let's use green, is going to be negative 3 minus 8, which is going to be negative 11. Okay, are there any questions with how we found those determinants? All right, so we're going to go through all the rest of them, go through them kind of quickly. And that is what I got. So far, you're just thinking that I asked you to find some basic 2x2 determinants, which I will most certainly ask you next week on test 3 and on test 3. I will ask you how to find a determinant of a 2x2, 100%. Do you have any questions with those values so far? Go ahead.
So apparently it's the case if you scale
Hold that thought. That's what I'm about to get to. Your executives. Do you have any questions with what you see on the board so far?
Previously, did we put like 1 over 11?
Yes, we put 1 over 11 in the determinant. Sorry, we put 1 in the inverse. Because if you're finding let's say you're finding the inverse of A, you would say, that top A, you would say 1 over 11, and then you would switch the 2 and the 4, and you would change the sign of the 3 and the 1. And so, yes, that is the same 11 that you were using there.
But the determinant is not the 1 over 11. It's just the 11.
It's just the 11. Yes, the determinant is just the 11. That's correct. Right, now, just like Joseph was fixing to allude to, we get all those B matrices that you see on the right-hand side. We got to those B matrices by performing an elementary row operation. In the first one, the first group of matrices, our elementary row operation was switching 2 rows. So from A to B, I said row 1, interchange row 2. Okay, now let's look at our second group. In our second group, I said, for the A matrix, I said negative 2 row 1 plus row 2 gives me a new row 2. That's what I said in the second group. And in the third group, I took A, row 1, and said 1/2 row 1 gives me a new row 1. So I performed those elementary row operations. So when you perform an elementary row operation on a matrix, I wanted you to see what happens to the determinant. So if you will flip your paper over to the back side, it says at the top, when B is obtained from A by interchanging 2 rows, the determinant of B is equal to negative determinant of A. So looking at this top one here, I got from A to B by switching 2 rows. And so what that did to the determinant of it was it changed the sign. And so that is what property 1 says of theorem 3.3. Okay, number 2 says when B is obtained from A by adding a multiple of row A to another row of A, the determinants are equal. So in this second group of matrices right here, I said negative 2 row 1 plus row 2 gives me a new row 2. My determinants didn't change. For the third one, it says, when B is obtained from A by multiplying a row of A by a non-zero constant, C, the determinant of B equals C times the determinant of A. Okay, so on this one, I went from A to B by multiplying by 1/2. So the same is true for the determinants. I went from A to B by multiplying by 1/2 in the determinants. So that's a theoretical interest only. It's not something that I will ask you specifically. I will ask you to find the determinant of all those, determinants. I will most certainly ask you. But this is what they're trying to show you, the relationship in 3.2 between the elementary row operations and what that does to the determinant. So that is where that came into play. Okay, the other thing that we'll talk about at some point over the Chapter 3 material is Theorem 3.4. So 3.4 says if you have a determinant equal to 0, then either you have a solid row of 0 somewhere, 2 rows are equal, or 2 columns are equal, or one row is a multiple of another row. And that's when you're going to have a 0 determinant. And that's something we'll talk about later. Now, as far as Chapter 3 goes, what we'll start by doing on Monday, which is after your test, on Monday we're going to start back over with Section 3.1. And in Section 3.1, we're going to talk about a determinant of a 2x2 and a determinant of a 3x3 and a determinant of a diagonal matrix and a determinant of a triangular matrix, which is going to come into play. And so we'll start back over from 3.1. So all I did today was 3.2 and show you the relationship between matrices, elementary row operations, and how that affects their determinants.